Great. That's the recording slide. Hi, my name is Greg Robertson. Welcome to the next EMEA vBrownbag. Tonight we have Raajiv Yadav. He will be covering an introduction to storage, going over everything from storage protocols to RAID to everything, really an introduction to storage, and covering a lot of that related to the VCP 5.5 blueprint. Yeah, if you guys have any questions, then you're more than welcome to write them in the chat area or tweet them with hashtag vBrownbag, and I will try and get them trying to say that word, asked. Raajiv. And yeah, this has been recorded. Apologies that a lot of the recordings haven't been going up on iTunes lately. Pretty much all of us guys who do the vBrownbag are also have day jobs, and we're very busy, and it takes a bit of effort to get it up, but we promise that we will get through the backlog. And for people that are attending VMworld US, please sign up for Tech Talks if you haven't already and you want something to talk about. If your session wasn't chosen for VMworld and you still want to do it, the vBrownbag, we'd love it on either the weekly one or even the Tech Talks at VMworld. So look on professionalvmware.com for the link to do that. And that's enough from me, so I will give Raajiv access, or at least make him the presenter, and then the hour is yours, Raajiv.
Hi, this is Raajiv. Can you see my screen now?
Not yet. I can now. Introduction to storage. Yeah.
Okay. Myself, Raajiv Yadav. I'm working for VMware partner as a solution architect, and working on VMware specifically from version 3.5, certified on 4.x and 5.x both, and some certifications from Cisco and IBM solutions as well. So today we will talk about the introduction to storage for what we do in vSphere part. So today's agenda will be on VCP-DCV track, specifically on the storage. We will discuss about storage protocols, what all RAID options, performance considerations for vSphere, and configuration for the storage, data stores, how to rescan data stores, PSPs, and what are data store clusters. Our primary focus will be on these things. So we'll start with storage protocols and the storage overview first. So primarily in vSphere we have two types of data stores, VMFS and NFS. VMFS is a VMware VMware own file system. It is specifically designed for vSphere. It's a clustered file system, and another type of data store used in vSphere is NFS. So protocols which we all or the type of disk which can be attached to vSphere are direct attached storage. We can use fiber channel storage, FCOE storage, ISPC, and NAS. Except for NAS, all other type of storage uses VMFS file system. For NAS, NFS file system is being used. So now we will discuss about the what all protocols overview total, and what does they support, what are their shortcomings, and what are the advantages of those protocols. So when we talk about fiber channel, we can have, it supports boot from SAN, it supports vMotion, it supports vSphere high availability, and distributed resource scheduling also. And it also supports raw device mapping also. Same with the FCOE protocol, it also supports all the functions which is supported by fiber channel also. In case of ISKC also, it supports all those functionalities which are supported by FCOE and fiber channels or protocols also. But when we talk about NFS, it does not support boot from SAN, and it also does not support raw device mapping also. DAS is only for direct attached storage part, and it does not, it only supports vMotion if it's within that box only, and it does not support raw device mapping also. So these are the type of technologies, what all protocols are being used, and how the data is transferred using these protocols. If we are using fiber channel, then the protocol will be FC and SCSI protocol. The transfer will be block access type, and the interface will be the HBA cards. If we use FCOE technology, then the protocol is FCOE and SCSI, and the data will also be transferred using block access, and the interface is CNA cards or software based on NICs or FCOEs, NICs which supports FCOE also. When we use ISKC, in that case protocols IP and ISKC protocols are used. In that also we use block access, similar to FCOE and fiber channel. In this case, either we use hardware based ISKC HBS or ISKC enabled NICs. When we use NAS technology, then we use IP and NFS protocols. This is a file level access. It does not access directly the LUN. LUNs are mounted by exporting those volumes, and the interface is always a network adapter in this case. Then we'll talk about types of storage. If we use local storage, then we can boot the VM from it, but we cannot do a vMotion. The data store type will be VMFS. It cannot support RDM. Cluster is possible, but it will not support DRS and VMware HA. If we use fiber channel disk, then we can boot it, that VM. We can use vMotion also. The data store type will be VMFS. It supports RDM, it supports clustering, and it also supports HA and vSphere DRS also. In case of SCSI, ISKC, LUNs, yes, it supports boot also. It supports VMware vMotion. File system type will be VMFS. It will use RDMs, but it does not support clustering. Same when we use NAS using NFS, then it supports vMotion. Data store type is VMFS, but it does not support either data store clusters, and also it does not support RDM also. And we just now discussed, there are two types of data store, VMFS and NFS. Data stores are used to hold virtual machines, templates, and ISO images. NFS volumes or NFS data stores are good for templates and ISO. Now we will discuss about the advantages of VMFS file system. It allows concurrent access to shared storage. It can be dynamically expanded. Now it uses 1 MB of block size, so we can store large virtual disk files. Prior to VMFS 5, in 3 and 3.3 VMFS, the block size was 1 MB, 2 MB, 4 MB and 8 MBs. So if we want, but the maximum size of VMDK was earlier 2 TB when we format the using 8 MB block size. But now the block size default is 1 MB and it supports more than 2 TB VMDK files also. The sub block size is 8 KB now, and it also supports on-disk block level locking also. Now one VMDK support can grow up to 64 TB. VMware vSphere supports NFS version 3. In some cases, we need to access RDMs directly, RDM raw device mapping. So in that case, neither we provide the data store using VMFS or NFS file system. The disk is directly presented to that VM. It's not only that we provide RDMs for the performance case. Whatever performance can be achieved using RDM disk, those can be achieved using VMFS and NFS data source also. We need to provide RDM in case of when we are using Microsoft clusters, or we use any SAN monitoring software which needs direct access to LUNs, or they need to use NPIB mode. In that case, we need to provide RDMs to those files. RDMs enables to store directly on the LUN instead of using any file system. The mapping file for the RDM is stored on the VMFS data store only, but that is only a mapping file. So when we create those LUNs, the performance of the VMs totally depends on the underlying disks and how we carve out those LUNs, how those LUNs are being presented to them, what underlying storage arrays we are using it, what type of arrays we are using it. So first we briefly talk about the RAID and the data striping part. Striping involves partitioning of those disks into smaller blocks. The stripe size mostly depends on the type of application we are using it. The most common schemas for RAIDs are 0, 1, 5, 10 and 0, 1. The most common RAID level is being used is 5. Nowadays 10 is also gaining momentum. RAID 0 is striping only. In this case, data is striped across groups of hard disks without any parity or redundant data. If one of the disks fails, the data is lost in that case because there is no redundancy. RAID 0 offers lowest level of protection when a disk fails. but at the same time it gives you highest level of performance and maximum capacity also, because there is no parity and there is no redundancy. So whatever disks are involved in that swiping, you will get the exact amount of disk space. In case of RAID 1, which is also known as the mirrored volume, it is fully redundant. Each block is written twice on the different hard. The advantages of RAID 1 is that it's always one writes and two reads whenever we are accessing the LUN or the data. There is 100% redundancy, and there is no rebuilding when a disk is failure, because whenever we put in newer disk, it simply copies it from the earlier replacement disk. Transfer rate per block is equal to single disk. It has the simplest RAID storage subsystem. The disadvantages of RAID 1 is it has the highest disk overhead, because it is half of the disks are unutilized. And if you are using a software RAID, in case of RAID 1, it will not support hotspur also. Now we come to RAID 5. In this case, parity is being used. It has the highest read transaction rate, medium write transaction rate, low ECC, parity disk means high efficiency, good aggregate transfer rate. But in case of disk failure, it has medium impact on the throughput, because it takes some time to rebuild the failed disk. What we should consider when we are sizing a physical storage, we should consider what size of LUN should be there, what should be the I/O bandwidth, I/O requests per second that LUN is capable of, disk cache parameters, zoning and masking. We should always present identical LUNs to ESX server, which type of array we are using it, active-active or active-passive arrays, and how we are exporting in case of NFS datastores. The main idea of presenting identical LUNs is that we can use storage DRS and datastore clusters also. It's easier to manage if all the LUNs are of identical size in that scenario. The main key points are that we should always try to use VMFS datastores to hold virtual machine files. NFS datastores are useful for a repository kind of things, for example ISO images or some templates. Shared storage is integral to vSphere features like vSphere, vMotion, HA, DRS. By using VMware vSAN, which is a recently introduced functionality, it enables low-end configurations to have HA vMotion and storage vMotion also, without requiring an external shared storage. virtual SAN clusters are directly attached server disk, which creates a shared storage design for those virtual machines. When we add more disks to the servers, those disks are directly placed or directly attached to those servers, but vSAN allows you to create shared storage for those virtual machines. This is the generic architecture of a storage array. Most of the storage arrays have two controllers. It can be active-active, or it can be active-passive, or alpha-based controllers also. It has interface ports. We call them as push interface ports. These ports are normally connected to SAN switches. Storage controllers has processors, cache, and behind those storage controllers we have disk enclosures. Okay, I will connect you to a demo storage. It's taking some time to connect. So we can click the host, then go to manage, then go to storage. We can see which all type of adapters we are using it from here, what all storage devices are connected. Here we can see that there are two local disks attached and there are three ISCC volumes are being attached. If you click on related object, data stores, here we can see have the list of all the data stores and which type of data stores are there. So all the two local data stores are VMFS 5. ISCC data stores are also VMFS 5, and we have one NFS data store also, which is version 3. If you want to add more data stores, again go to manage, go to storage, we can have new data store. Then we can select which type of data store we want. Then whether we can define it, which VMware version we want it. So we'll create one ISCC data store. So I have a vSwitch 1 where I am having a dedicated path 1 NIC assigned for the ISCC traffic. So we'll create one data store. So this is the console of Netgear box where we can have NAS and ISCC data stores. So currently we have three. You can see that we have three ISCC volumes. Same three ISCC volumes are currently presented in the ESX server. So we will create one new volume. Name it as test learn. So I am creating 100 GB. So once this run is created, then we need to assign it. So here I already created one group by name of ESX where IQN number is already given. So we can go back to vSphere client. Okay. If click on add storage. So currently we can see that we are not able to see the LUN which we have just now created. So but if we do a rescan, then we should be able to do it. Either we can create it from web client also, or we can create it from the SIG client also. We will create it, this one from web client. We go to storage, we can create a new data store. Here we can select it whether we want VMFS or NFS. So this is the 100 GB LUN which we just created. So we can see that VMFS 5 allows us to create 2 TB plus LUN. But if we create using VMFS 3, the LUN size will be less than 2 TB. We have just created it. Now we will be able to see it here. We can again do a rescan. Here you can see that we have this 800, this 100 GB LUN which we just created is now presented to ESX servers also. We can always select a LUN and we can unmount it. If we delete it, the data will be wiped off. If we unmount it, just it will be unpresented from the ESX server. Like say this is one NFS store. We'll just unmount it. So that I can show you how to mount it again. Go to manage, storage, new data store. This time we'll select NFS. We need to give a data store name. Then we need to provide the server for the NFS. My NFS server IP address. Then we need to give the folder name where the NFS export is there. In NAS we have an option of NFS as read only also. So we can create some templates or images, ISO images, and we can mount them as read only. We click on finish. So here you can see that we have the test NFS here now. Same way, if we want, we can unmount an ISKC volume also. So if we have multiple hosts, we can decide it from which host we want to unmount it. Since we have only one host, we need to unmount it from here only. So after unmounting, if we do a rescan, it will not be visible here after that. So you can see that it is unmounting. So it is already unmounted and it is inaccessible now. So if I want to add it once again, then I can again go to new data store. And I can again re-add it. So now we'll discuss about what all options are available in DRS. What if we don't use DRS, and what will be the advantage if we use DRS? If we are not using DRS, then we need to identify the data store with most disk space and lowest latency. Then we need to confirm which virtual machines we are placing on which data store, so that we should not have any kind of conflicts. So we should not place two high I/O intensive VMs into one data store. Then after deciding the data source, we create virtual machines, and we hope that there will not be any I/O contention. But if we are using vSphere data store DRS, then the placement will be automated. We just only need to create virtual machine, and we need to select the data store cluster. It will automatically, based on the available capacity, maximum available capacity, and the maximum I/O availables in a specific LAN, it will automatically place that VM in that specific LAN. In addition to it, it will balance also, so that there should not be any bottlenecks or lack of space issue. So it will monitor that, the cluster will monitor the VMs for the space and the I/O. In addition to that, we can have VMs and VMDK affinity and anti-affinity rules also. If we have two high I/O intensive VMs, we can always have an anti-affinity rules, so that they will never be placed in one data store. Or we can have affinity rules also, so that if we want a database VM and a middleware VM, it will always to be in the same LAN. So we can write an affinity rule also for those. Likewise, VMs, we can have affinity and anti-affinity rules for VMDK files also. So vSphere storage DRS provide us the initial placement of virtual machines and VMDKs based on the available space and I/O capacity. So load balancing will be done between data stores in a data store cluster using VMware storage vMotion, and it will also do a load balancing using storage vMotion based on the I/O matrix and latency. It also includes, likewise we discussed, affinity and anti-affinity rules. In case of VMDK affinity rules, it will keep virtual machines VMDK together on the same data store. We can have VMDK anti-affinity rule also. In that case, VMs will be distributed across different data stores. We can have virtual machines anti-affinity and affinity rules also. And during, unless and HA is triggered, affinity rules cannot be violated. They will be violated only in case of if HA is triggered or any of the data store fails. So when we are using storage DRS, the integral part of using storage DRS is creating a data store cluster. Data store cluster is similar to host clusters, wherein we group similar hosts together. In case of data store cluster, we group similar data stores. It is simply a group of data stores, and it will in case of data store cluster, storage DRS is used to load balance the capacity and the I/O. We can have a profile driven storage also, where we can tier the storage based on the performance or the SLA of the specific VMs. We can view all the compliant storage resources. Based on that, we can choose it. Based on the VM characteristics, it will automatically choose which type of storage will be suitable for that VM workload. So it will always utilize the correct storage as per the resources, not just hoping that we are placing in the right tier. So data and VM administrator need not to bother about it, whether that it is placing the VM in the right storage, the right data store. So just based on the business and application goals, the VM can automatically be placed in specific tier. It will help to improve the storage utilization and the efficiency. It also helps in disk space management because it will have thresholds. We can have advanced thresholds also. Storage ERS will monitor the space utilization of those data stores. It will also measure the IOs also for those specific data stores. It will keep a check on the thin disk snapshots. It will give the vCenter alerts based on those thresholds. There are certain new features in the vSphere 5.5 storage. Out of that, one of them, the great advantage is the size of those VMDKs. Now the support is for up to 62 dB of VMDKs. In the performance segment, there is support for end-to-end support for 16 GB FC backend. There is one more feature for performance. It's vSphere Flash Read Cache, but it is only available in Enterprise Plus. This feature is not available with other editions. In case of availability section, there is some more enhancement for Microsoft cluster. Like we can now have round robin policy in case of Microsoft cluster. Earlier we used to have only fixed path policy. Now vSphere application has multiple point-in-time snapshots can be there. Storage vMotion and vSphere DRS compatibility is also there with vSphere application. If we are using vSphere application, even though VMs move from one data store to another data store, then vSphere application doesn't halt. It understands that it has those compatibility is there. In case of operations, we have VI enhancements and VMware heap enhancements also. That's it for me today. Any other specific questions?
No, we can take any questions coming in. Yeah, guys, if you have any questions, please stick them in the question area or even on Twitter with hashtag vBrownbag, and I will get them asked.
Can you type in your question?
No one's typed in a question as yet. Okay. Doesn't look like anyone has any questions, which is good. Yes. It means you answered all their questions even before. Cool. Thanks, Raajiv. That was really good and informative. It was a good intro to storage.
Thank
and yeah, thanks everyone for joining. Look like anyone has any questions. People are just saying thanks. So yeah, thanks Raajiv. That was a shame. I think it must be like 12:30 for you at the moment. That's quite late. Yeah, guys, I think next week is the final one. Sorry, there's two more. So next week is Frank Bruchel covering virtual machine management and resource utilization, the VCP track. And then the week after that is Mike Brown covering HN DRS, the VCP track. So, yep, hopefully everybody can join us next week. Thanks for joining tonight. Thanks again, Raajiv. And the recording I will try and encode and spec up tomorrow. And then hopefully we get to the backlog of the iTunes also. Thanks, everybody.
Thank you.